Hello everyone, I'm BOWEN from China, and today I will introduce AC motors and brushless DC motors with my three friends, and obviously I'm the first presenter. And the first one, I will divide our content for four parts, and the first one is different types of them. So what is AC? AC motor is a device that converts AC power into mechanical energy. The AC motor is mainly composed of an electromagnet winding or stator winding for generating magnetic field and a rotating armature or rotor. The motor is made by using the phenomenon that the electrified coil rotates under force in the magnetic field. And their feature, AC motors have a higher working efficiency, no smoke, no pollution to the environment, and less noise. Because of its series of advantages, it is widely used in industry and agriculture production, transportation, national defense, commercial and household appliances, medical appliances, and other fields. And the AC motors have divided for two types. Synchronous AC motor. The structure of the synchronous motor is really the same as the of the alternator. It differs from the base of the induction motor in that the rotor of the synchronous motor is a protruding magnetic pole within a coil, and another exciter is used to collect DC AC exciting current. And another type is induction motor. The external and the internal structure of the induction motor rotor is a rotable conductor, usually in the shape of a squirrel cage. The stator in the non-rotating part of the motor, the main task is to produce a rotating magnetic field. And one question is how they work. And the first, synchronous AC motor have two main ways to start. A synchronous starting method. A cage starting winding is installed on the main pole board of the motor. When starting, the excitation winding is short connected by resistance, and then the stator wind is connected to the power grid. Depending on the asynchronous electromagnetic torque of the starting winding to make the motor speed up to nearly synchronous speed, and then the excitation current into excitation winding. Establish current into the excitation winding. Establish the main pole magnetic field can rely on the synchronous electromagnetic torque to pull the motor rotor into the synchronous speed. And another method is auxiliary motor starting. Generally, the induction motor with the simple number of the synchronous motor. Capacity is about 10 to 50% of the main machine. It's selected as the auxiliary motor, which drives the main machine to close to the synchronous speed. Then switch the power supply to the main stator, and the excitation current is fed into the excitation winding, which leads the main machine into the synchronous speed. And another type, induction motor, have three methods to start. First is soft start. At present, the electronic soft start facility all use the voltage regulating circuit of the thyristor. Its circuit structure is described as follows. 6 thyristors are connected in series to 3-phase power supply after 2 inverse parallel connections. After the starting signal is sent by the system, the data calculation of the computer control starter system is carried out immediately so that the thyristor can transmit trigger signal, so that the conduction angle of the thyristor can be controlled according to the given transmission. Output adjusts the output voltage to achieve motor control. And second is direct start. This kind of starting mode is the most basic and the simplest one in the motor starting mode. Firstly, the motor is connected with the power grid by means of knife switch. At this time, the motor starts and runs at the rated voltage. The characteristics of this mode are less investment, simple equipment, and less quantity. Although the starting time is short, the starting torque is small. The current is large, and it is more suitable for the application of small capacity electricity. And the third method is spark start. Due to the shortcoming of direct starting, step-down starting occurs. This starting mode is suitable for both no-load and light-load conditions. Since the step-down starting mode realizes the limitation of starting torque and starting current at the same time, it is necessary to restore the working circuit to rated state after starting.
Hello, I'm FANG YUFEI. Now I will talk about the applications and how they are controlled of the AC and DC brushless models. First, we talk about the applications of AC models and DC brushless models. AC models. AC models are low-cost and high-efficiency mechanisms used in a large variety of applications. AC models offer a simple design consisting of a magnetical-driven copper-wooded stator and a rotor mechanism. In AC motors, the input alternating current creates a rotating magnetic field over the stator, which ultimately moves the rotor, which is connected with an output shaft. From heavy industrial to household environments, different types and categories of AC motors have applications wherever electrical appliances are utilized. AC motors are mainly consisted of synchronous models and induction models. First, we talk about the synchronous models. Synchronous models. In synchronous AC models, the speed of rotor is proportional to the stator. They both rotate in a synchronized fashion. These models are known for their efficiency in maintaining the power of overall system and can be used as stepper models in some cases. Synchronous models find their major applications in areas where accuracy is important. For instance, in clocks, timers, electromechanical robots, metering pumps, speed controllers, and other industrial processes. Also, synchronous AC models are specifically used in high-precision drill machines and similar devices. Now we talk about the induction models. Induction models are the most common type of AC models used in daily life processes, and their output rotation speed is proportional to the applied frequency of alternate current, used in almost every process. Induction models are mainly used in water pumps, kitchen appliances, fans, and air conditioners, automobiles, and common industrial machinery like boiler pumps and compressors. AC induction models are efficient and flexible, which allows them to match the load demand for almost any type of electrical application. Now we talk about the DC brushless models. For industrial applications, brushless DC models are primarily used to serve actuation, positioning, and variable speed applications where precise motion control and stable operation are critical for the satisfactory operation of the manufacturer or industrial process. They are commonly used as linear models. That's the application of AC models and DC brushless models. Now we talk about how they are controlled. The speed of a DC model is controlled by varying the armature windings current, while the speed of an AC model is controlled by varying the frequency, which is commonly done with an adjustable frequency drive control. That's the difference of AC model and AC model. That's all. Thank you.
Hello everyone, my name is KEQIN. In the introduction, we have a primary understanding of AC and DC motors. Next, I will summarize the advantage and disadvantage of AC and DC motors. In DC motors, it has the following four characteristics. First, the voltage waveform of the DC generator is better and is less affected by electromagnetic interference. Second, DC motors speed regulation, which is WANG. Speed regulation changes and smooth. Third, the DC motors has storing overland capacity and large starting and braking track. First, due to the excess of community is manufacturing complexity and high cost. In AC motors, there are two outstanding advantages. First, AC motors manufacturing is relatively cheap. Second, slab steering, easy maintenance, and lower inversion requirements and air civilian. Sometimes there is also an accept of problems in AC motors. For example, starting and speed regulation is poor.
Hello everyone, my name is XIAOPENG. I will talk about AC and DC motor converting. For example, converting 5.5 kW AC motor to 5.5 kW DC motor. 1. Under the same load, the torque of AC motor will be obviously greater than that of DC motor at low speed. In terms of specific energy, P equal to UI plus time is the work it consumes. Current is the same, voltage is the same, power is the same, of course. But in terms of usage, under the same load, AC machine sells more electricity than DC motor. There is still work in DC motor. The power factor of DC motor is relatively low. However, when it's used in speed regulation, the DC motor can only produce a huge instantaneous torque and stop torque, but also maintain a specific power output at different rotational speeds, which AC motor can't achieve. 2. DC motor can get higher output torque than AC motor at the same power. 3. DC motor has low working voltage and large volume, and the same power consumption. AC motor has high working voltage and small voltage and the same power consumption. If the same output power and torque are needed, the volume of DC motor is small. 4. DC motor is more expensive than AC motor. Besides, reading commutator is added. The reading insertion process is more complex. That's all. Thank you.